Okay, hi everybody. We will be doing the AS chemistry course, and this is lecture two because I have recorded lecture number one where we discussed about the IUPAC, that how we're going to name the compounds. So this is now more about the functional groups, which will we be using in the organic chemistry. I hope that you have an idea about what functional groups are. See, functional groups are all of those things that can be a bond, that can be a compound, that can be an atom, that can be an anything, which which does what? Which basically gives a characteristic property to a substance. Because of the presence of the functional group, a compound can be identified. For example, yeah, this is what I said. Very happy writing because this is, I feel these happy faces give you a good feel of learning as well. So what functional group is? Functional group basically determines the physical and chemical properties of the molecules as well. It not only gives a characteristic property, but it also tells that how a compound is going to behave physically, how a compound is going to behave chemically as well. There are few definitions. Those definitions can be asked in the paper, and these definitions can also be these needs to be learned as well. So, for example, let's suppose homologous series. What it is, homologous series is basically is a group of compounds, and that group of compound that have same functional group, same general formula, and they have same chemical properties as well. I repeat, these are the organic compounds, or these are the group of organic compounds which have what? Which have same functional group, which have same general formula, and that have same chemical properties as well. All of these groups which have same functional group, same general formula, and same chemical properties, they will be kept in a group. So that group will be known as homologous series. What is general formula? General formula represents the homologous series of any compound. For example, if a homologous series is an alkane, then the general formula of alkane will be specific. If the homologous series is alkene, then the general formula will be specific for that as well. So these are basically the ones which are helped to calculate the number of hydrogens which are present in a compound. So this is what we call general formula, which is specific to the homologous series. Then comes the structural formula. Now, what structural formula is? It shows that how the atom are bonded to each carbon atom in a molecule. That is what we represent in terms of the structural formula. For example, let's suppose that if I have to give the structural formula let's suppose I'm giving you an structural formula, which is this. I'm attaching two carbons with an oxygen, then a hydrogen is attached to it, and then there are hydrogens, and there are hydrogens, and there are hydrogens, hydrogens, and hydrogens. So here I have connected all of this. Now this kind of a formula where we are connecting the carbons and hydrogens and oxygens to each other in giving a clear picture that which one is attached to what. This is what we call structure formula. All right. Then comes the displayed formula. Now, what displayed formula is? Displayed formula is basically a 2D representation. 2D representation of what? 2D representation of an organic molecule. This is, let's say, generally related to what? This is generally related to the organic molecules normally. Organic molecules showing all of its atom by their symbols and their bonds. It can be a single bond, it can be double bond, triple bond. It can be this. Now, what is the displayed formula? For example, displayed formula is CH4. For example, the displayed formula can be C3H8. The displayed formula can be in multiple ways. It can be image. It can be image. It can be represent like this as well. It's a display. You are just displaying it. So display formula can have multiple representations as well. Then comes the skeletal formula. The skeletal formula is a very simplified version of any compound. That's what we call the skeletal uh, formula, and generally it's also be related to the organic compounds. Let me give you an example. For example, there's this skeletal formula, let's suppose. Here, this is a skeletal formula. And this skeletal formula is for what? This is for propene. This is how I draw the skeletal for propene. Now, if I have to draw the skeletal formula for isobutene, so that isobutene can be like this. This is the skeletal formula. Sometimes we do not even write these carbons as well, because the skeletal formula is the most simplest version of displaying something. So yeah, they can ask you about the skeletal formula, they can ask you about the display formula, they can ask you about the structural formula as well. Now we will see one by one. As far as alkene is concerned, now these are the homologous series which you need to learn. Alkene has a general formula CnH2n. It has this as a structural formula, this as a displayed formula, and this displayed formula is a propene. See, if it has two carbons, then the name of the compound will be what? The name of the compound will be ethene. And double bond over here is the functional group. And if there are three carbons, then three carbons will be known as propene. Now this R represents what? This R represents alkyl radical, which means it can be any compound with a carbon attached to it. For example, it can be CH3, it can be C2H4. These are all alkyl radicals. Now, alkyl is another group. What alkyl group is, I'll tell you in a separate video that what alkyl group is. For this video right now, what you all need to do is you need to learn what is alkene. Alkene is the homologous series which has a general formula with CnH2n. It has this structural formula. This has this display formula and skeletal formula. After that, we have halogen alkanes. Halogen alkanes at what? Halogen alkanes are CnH2n plus 1x. This X represents what? This X represents a halogen. This represents a halogen. Now, what halogen this represents? This halogen can be Cl2. This halogen can be F2. This can be I2. This can be anything. But we do not use F2 like fluorine more often. Why don't we use it? Because it is highly reactive. So we use chlorine and bromine most of the time, because chlorine and bromine, they give the, this chlorine and bromine, they give, the medium reactivity. However, iodine and astatine, they are very less reactive. However, fluorine is highly reactive. So if you have to represent the structural formula of all of this, the structural formula can be represented like this. And then the name of compound, if it has three carbons, then the name of the compound should be halogen propane. This is the displayed formula, and this one is the skeletal. After that, we have alcohols, and alcohols, the formula is CnH2n plus 1OH. The structural formula is ROH. Name of the compound is propane 1-ol. That's how you write it. Propane represents the number of carbons. If it's propane, that means how many number of carbons are there? Three number of carbons are there. One means that this OH group is attached on the first carbon. See, if you will see my IUPAC video, then you will get to know more about it. Whenever the functional group is attached, we start giving the numbers from there. So if functional group OH, which is the functional group of this, if this is attached to the first carbon of this carbon, then this will be known as the first carbon, then the second carbon, then the third carbon. So the displayed formula is this. And this is the skeletal formula. In the skeletal formula, as I told you earlier as well, in the skeletal formula, we generally do not represent or do not write the carbons. We just represent it in the most simplest version. All of this you need to learn. If you want to excel in organic chemistry, this video and whatever I'm teaching in this particular video has to be on your fingertips like anything. Yeah, it means if you do not learn this, then you will not be able to progress in this at all. Then you have another homologous series, and then homologous series is aldehyde. The difference is the formula CnH2, and the difference is of this functional group. See, these are the functional groups which are different from each other. Achha, why didn't I talk about alkane? Because alkane is the first one with the general formula CnH2 and plus one, and alkane has no functional group, all right? In alkene, I repeat, the functional group is the carbon-carbon double covalent bond. This is the functional group, carbon-carbon double covalent bond. This is the functional group. You need to learn it. When we say halogen, this is the functional group. This is who is responsible for all kind of reactions. Then in alcohol, OH, this is the functional group, the one which is responsible for all kind of reactions. Aldehyde, CHO, is the functional group responsible for all kind of reactions. Now, if I have to see the structure of CHO, then how does it look like? With this carbon, with the double bond, oxygen is attached and a hydrogen is attached. And then the further number of carbons can be attached. It can be 1 carbon, 2 carbon, 3 carbon, 4 carbon, depending on the compound. Let's suppose we see the structure of propanol. Now, when we say propanol means I have 3 carbons. So first carbon, second carbon, and third carbon. Why did I put the number of 1 over here? Because the functional group is attached over here. Functional group is, that means an H and O. And this will be the display formula. If I have a double bond, then we represent these 2 lines with the double. After aldehyde, another homologous series is ketone. Now, what ketone is? Ketone has basically a combination. A combination means there is this oxygen over here, and then here it has carbons, and here it has carbons. This oxygen is basically the functional group in ketone. So on this side, we say CnH2n plus 1 is the formula, and here it is CmH2m plus 1. It is just to differentiate between 2 different side of carbons that are attached. How we use it, we will see it in the next video when we'll be describing in details about the families. The structural formula, whenever an oxygen is attached, generally in the organic compounds, and an oxygen is attached to the carbon, it's always with a double bond, always with a double bond. Either you talk about carboxylic acid, you talk about aldehyde, you talk about ketones, it's with a double bond, and then the other alkyl radicals mean the carbon compounds are attached to it. Again, I'm almost taking the 3 carbon compounds. Let's suppose I've taken propanone over here. Propanone means 3 carbons, all right? With this central carbon, in case of ketone, always this oxygen will be attached with the central carbon. I repeat, in ketone, this oxygen will be attached always with the central carbon, and the other 2 carbon will be attached to it. And this is the skeletal formula. I hope it makes sense. If does not, you can always ask the question in the comment section and I'm going to reply it. Now, this is the carboxylic acid. The formula is CnH2n plus 1 COOH. You have to learn the structure of this functional group. Like you have to learn the structure of CHO. CHO means a functional group of aldehyde. You have to know that ketone has this C double bond with oxygen core. You have to know that when it comes to alkenes, then there are 2 double bonds between the carbons. Again, it has to be on your fingertips. So, sorry. This is how do we draw this structure? We draw this structure like, what do we do? This structure can be seen over here like this. It has 1 carbon, it has double bond with oxygen, and then it has an OH group. Name of this compound is propanoic acid. For ketone, it was propanone. For alcohol, it was propanol. For alkene, it was propene. For alkene is propane. Then this is the displayed formula. This is how we displayed, and this is the skeletal formula for ester. In ester, even you have this 1 carbon, but the difference between ester and ketone would be that there are two oxygens attached over it. In ketone, there is only one oxygen attached over here. As far as ester is concerned, in ester, there are two oxygens attached over here. So this one is ketone and this one is ester. All right. There will be so many reactions where you will going to study that how ester will going to form. However, for now, we have taken the structure of methyl propanoate. Methyl means CH3. And here the structure of the displayed formula is there for sure. Then you have amine. Now, amine means the general formula CnH2n plus 1 and the functional group. This is the functional group. And the name of the compound will be propylamine. Now, what do we mean by propylamine? Propylamine means three carbons. And in three carbons, a nitrogen is attached with two hydrogens, and this is the skeletal formula as a representation. Nitrile, the structural formula. See, now the more I'm moving towards the slide, the more I'm more focusing on the functional group only. But this is the importance of the functional group. So this is the functional group CN. CN means with one carbon, nitrogen is attached, but nitrogen is attached with three bonds. The name is propane nitrile. I've taken only one compound, a compound which has three carbons, which was propane, which was propene, which was propanone, which was propanoic acid. Just make you understand that this three carbon compound, how does it really going to change when the functional group will be changed with this. So in this wave formula, this will be the first carbon, second carbon, and the third carbon, and the name will be propane nitrile. And this display formula can be represented like this. When it had double bonds, then two lines were there. It had triple bond, and three lines are over here. Right. So this is the task for you. You can pause the video and you can see the skeletal formulas for the following molecules. You can draw it yourself. And by drawing it yourself, you can see whether, you will be able to do it or correctly or not. So just pause. Thank you. And wait for the next video.